Hello from Mindpads. TOK Essay November 2017. Topic number 6. The production of knowledge seems to require creativity at every stage of the process. Discuss this statement with reference to two areas of knowledge. Knowledge question 5. In what ways production of arts and music require creativity? In the production of music, just like a symphony requires several units of an orchestra to play together to bring the fragments to life, several sections of the brain need to work together over the stages of production process to bring out beautiful and original work. Neuroscientists use functional neuroimaging methods to examine musical improvisation as a prototypical form of spontaneous creative behavior for rappers and jazz musicians, and found that spontaneous improvisation, or the process of spontaneous musical composition, independent of the degree of musical complexity, is characterized by widespread deactivation of lateral portions of the prefrontal cortex together with focal activation of the medial prefrontal cortex. The creative process occurs outside of the conscious awareness, self-monitoring, and control. C1 Lee and Alan Brown, neuroscientists at the U.S. National Institute on Deafness and Other Communication Disorders, compared the brain scans from rappers taken during freestyling to those taken during the rote recitation to see which areas of the brain are used during improvisation. In a similar study, Brown and Charles Lim, doctor and musician at Johns Hopkins University in Baltimore, Maryland, looked at MRI scans from jazz musicians. During a jazz performance, musicians utilize a composition's underlying chord structure and melody as the contextual framework and basis upon which a novel solo is extemporaneously improvised. Knowledge question 6. In what ways production of knowledge in area of sciences require creativity? In sciences, regardless of the focus and understanding required in single disciplines, we need to have a multifaceted approach to cooperate and collaborate between disciplines to solve complex problems and understand complex events of our present world. Fresh perspectives and new insights are sought after. Preconceived notions, preconceptions, or a linear approach only point to the associations that are obvious. Framing and exploring knowledge issues with neither one right solution nor the obvious solutions enables the researcher to have creative insights. Science in itself is a creative quest, an ongoing journey, a quest for knowledge about the natural world. Sciences have a defined method and means for knowledge production, yet sciences need a good portion of inductive and abductive thinking. Whether it is theoretical physics or big data, creativity is required to look beyond the equations, facts, and figures. Scientists are expected to develop ideas that are novel and useful. Knowledge question 7. In what ways production of knowledge in area of mathematics require creativity? Mathematician G.H. Hardy, in his book A Mathematician's Apology, writes that a mathematician, like a poet or a painter, is a maker of patterns. I am interested in mathematics only as a creative art. In his later years, Hardy admitted that his own time as a creative mathematician was finished, and that exposition, criticism, appreciation is work for second-rate minds. Mathematicians are driven by very creative and aesthetic instincts. Both for problem solving and inquiry, mathematicians require creativity. Creativity in their work enables them to look for options, to choose, to make judgments on their way to solutions. In The Life and Survival of Mathematical Ideas, the British mathematician Michael F. Barnsley discusses how a specific mathematical topic can be viewed as a creative system. The forms emerging from this system are fractals. The mind of a mathematician, he argues, provides a locus for creative systems, a place where mathematical structures live and evolve. He makes a parallel between biological forms, such as plants, and mathematical forms. An example of mathematical forms are the geometric building blocks of points, lines, and planes. Their DNA consists of the equations that describe points, lines, and planes. The forms evolve and adapt as they are passed on through generations of mathematicians' minds. That's all for today. Thank you for watching. For additional content, visit us at mindpads.org, and for any queries, write to us at mindpads.org@gmail.com.